Well, hi, hello, and welcome. In this video, we make our transition into the world of linear algebra, and the world of linear algebra includes a whole lot of matrices. Matrices is the plural of matrix, and a matrix is just an array of numbers in rectangular form. We usually use these brackets to indicate that we're working with a matrix, and we write numbers down in rows and columns. It's rectangular, so every row has the same number of numbers. Every column has the same number of numbers, but those are not necessarily the same number of numbers. So this is what we would call a 2 by 3. There are 2 rows, and there are 3 columns. So this would be called a 2 by 3 matrix. And in this particular lesson, we're interested in augmented matrices because the instant application for us is that we're going to turn a system of equations into an augmented matrix. And here's what we mean. So here's a system of equations. X plus y equals 8. Negative x plus y is negative 2. We want to turn that into an augmented matrix. Why? Because it really doesn't matter if this is x or y, or m and n, or j and k. The letters themselves are irrelevant. The fact that there is one of these and one of those adding up to 8, and negative one of these and one of those adding up to negative 2, that's what matters. So the augmented matrix says, let's get the letters out of the way and the operations out of the way, and let's just focus on the structure of the system. So what does that mean? Well, the augmented matrix would have 2 rows and 3 columns because there were 2 rows and really 3 columns here. And we would just pull the coefficients. 1, 1, 8, negative 1, 1, negative 2. Some people draw a vertical bar there to sort of indicate that the constants are on this side of this equals sign. I'm doing air quotes like you can see that. That's just silly. Really? I have my own YouTube channel. That's ridiculous. This vertical bar is sort of like, here are all the equal signs. So this is the augmented matrix that represents this system here. So solving the system is just like making sure there are ones on the main diagonal and zeros everywhere else. Zeros everywhere that's not on the main diagonal. How do we do that? Well, as we read, we do those with row operations. So there are a couple of things we can do with row operations, really 3. We can swap rows, that's allowed. We can multiply a row by a constant, that's allowed. Or we can multiply a row by something and add it to this other row here and let that result replace what's currently there. Now, we already have a 1 in this spot, and that's a goal, so we'll leave that there. But we need a 0 in this spot. How do we get a 0 in that spot? Well, there's a 1 here and a negative 1 there, so if we took row 1 and added it to row 2 and left the result in row 2, that would make a 0 here because we'd have 1 plus negative 1 is 0, and we'd leave. But whatever we do there, we've got to do all the way across, or else we are changing the value of something that really is very important. So we're going to do this operation. Row 1 stays as is. We add row 1 to row 2 and leave the result in row 2. 1 plus negative 1 is 0. 1 plus 1 is 2. 8 plus negative 2 is 6. And now we have a 1 in this spot where we need and a 0 in this spot where we need. Now, to solve the system, we need a 1 in this spot. Now, how can we do this really, really easily? What does this row represent right now? This row represents that 0x's plus 2y's equals 6. And from there, I'm pretty sure you know what y is. How do you know what y is? Because you just mentally divided by 2, divided by 2. And that's one of the acceptable row operations. We can take a half of a row and leave it in that row. So row 1 remains the same, but in row 2, half of that, half of that, half of that, right? So now we know 0x's plus 1y is 3. 0x's plus 1y is 3. That's great. So now we know what y is. Y is 3. If we wanted to take this all the way, we could try to get a 0 in that spot. And now we use row 2 to get row 1. If we take row 2, take its opposite, and add that on, -1 plus 1 would give us 0. That would do the trick. The opposite of row 2 plus row 1, store it in row 1. We could do that. Row 2 stays the same. And in row 1, opposite of 0 plus 1, that's unaffected. Opposite of 1 plus 1, that's 0. Opposite of 3 plus 8, that's 5. And now you've got the solution staring you right in the face. 1x plus 0y is 5. 0x plus 1y is 3. The solution is 5, 3. We don't need the x's, we don't need the y's, we just use an augmented matrix and some row operations to achieve the result we're looking for. I'll try one more time. Let's solve 3x minus 2y is -16. 6x plus 5y is 13. And I'll go a little bit more quickly here because not only have you read, but you've already seen, and also you are able to hit the pause button when you need to. So goal 1 will be to get a 1 here. How do we do that? We take 1/3 of row 1 and stick it in row 1. So 1/3 of that, 1/3 of that, 1/3 of that. Row 2 unchanged. Now we want a 0 here, and to do that, we take this row and linear combine it with that row. If we take -6 of row 1 and add it to row 2, leaving that result in row 2, that does the trick. Row 1 stays the same. And what's row 2? -6 plus 6 is 0. 12/3 is 4 plus 5 is 9. And 32 plus 13 is 45. Now from here, we know what y is, because we know that 9y is 45. But just to drive the point home, let's do that. Row 1 remaining the same, and row 2 becoming this. And then from here, we could solve the system. The first equation now is x minus 2/3 y is -16/3, but we know what y is, so we can solve. Let's just finish using the matrix method, getting a 0 there. How do you get a 0 there? Well, you'd have to take 2/3 of row 2 and add it to row 1 and leave the result in row 1. So 2/3 of 0 plus 1, 2/3 of 1 plus -2/3. 2/3 of 5 is 10/3, plus -16/3 is -6/3. And the solution is staring us right in the face. X and Y are -2 and 5. When we gather, there's more to talk about. We'll make sure we know what to do and how to do it. I'll see you when we're there.